I think maybe one positive message is that it opens creativity for pretty much anyone. So if you thought before, let's say that you had an idea for uh, a project, a startup, whatever, and like, oh, where do I find my technical person and how do I create a team and marketing? Today, a team of one can do so many things. And again, maybe like even like a small team of like a couple of people, we run thousands of simulations per second to stress test different scenarios before we provide a very detailed analysis of the decision with a very clear audit trail, hashed, by the way, 256 bits hashing. So the decision could be protected and be replayed as needed. And then finally, if people want to further execute and automate this execution, we can provide that as well.
Hey guys, welcome to another episode of Reframe First. I'm Alexei, and let me introduce our today's guest, Yuval Yatskan. Yuval is CEO at ePlane AI, and also Yuval has been over 20 years in SaaS industry, worked for some big tech, and nowadays ePlane AI. So, hi Yuval, nice having
Hi,
you.
thanks, Alexei, for having me here.
Awesome, thanks for joining. So, in the pre-call, we discussed a bit about what you do, what you built, and you built something, and it would be really great to discuss and to explore further what you built. So it's something AI related. Could you tell us more about what you do there and how you came to the product?
Yeah, absolutely. Just maybe a little bit about ePlane AI to give the context. So we started our way back when in 2016 as a marketplace for the aviation ecosystem. And around 2023, we decided, now with the rise of Gen AI and the need for more critical accuracy in execution, to transition to point AI based solutions, because we were sitting on like huge data that was very unique, and thought that we can use this much better in this way rather than just being a marketplace. And since then, we've been focusing mostly on the aviation ecosystem, so different types of customers, again, serving them with different AI-related needs, anywhere from dynamic pricing to certain automations and different types of intelligence, inventory management, etc. But the most recent development to me is that what's very exciting, and I think is worth the entire conversation, is what we're about to launch in a few weeks, a solution that we called AeroGenie. And this is something that far surpasses the aviation ecosystem, has myriad of other use cases, but it is our agentic decision engine. And what it does, in a few words, and we can talk more about this, again, I can talk about this for hours, is that it ingests data from different places. Now, obviously, with MCP, it becomes even more relevant that you can pretty much anything MCP related or any shareable database or anything that you want to upload, it can ingest, but also automatic triggers. Then, unlike traditional LLMs and commercial chatbots that you have today, that are limited in what they can ingest. I mean, they have not only limitation, like say ChatGPT can upload up to 512 megs or so, but usually because they have to to reply with a very quick answer, they have to make some trade-offs, skip lines or skip pages, and approximate the answer. And because we built AeroGenie using Mojo and a few other optimizations, this is thousands times of much faster than the equivalent Python. So we don't hallucinate. We actually read the entire data, join all the tables. And the most interesting part, we run thousands of simulations per second to stress test different scenarios before we provide a very detailed analysis of the decision with a very clear audit trail, hashed, by the way, 256 bits hashing, so the decision could be protected and be replayed as needed. And then finally, if people want to further execute and automate this execution, we can provide that as well. And again, we're very excited about this. We can talk about different use cases, but um, as you can hear, I'm very passionate about this. But I'll stop here just to see if this is something that is interesting to talk about.
It absolutely is. It for sure is. I got a lot of like technical questions, and not only technical. But could you tell about some examples of where do you use it? Like in the pre-call, you told me about some legal case, but and
Yeah,
it
yeah,
was
yeah, yeah.
all
I'm
of a
happy to
sudden
give some
they did a
initial.
variation, and all of a sudden it solves legal problems. Could you tell like few examples of what it
Yeah,
does?
it was actually very surprising to us because when we built this, we didn't really know what to expect. Just a bit of more context. A very large aviation-related company approached us to build a prototype, like a solution like that. And when we built this, and surprisingly, relatively quickly, uh, we didn't know what to expect. We realized very quickly that it could do much more than what they asked. And just to give some examples that we actually stress test this, and we've been testing this 24/7 in different ways, just to make sure that it's stable and does what it is. And we keep on being surprised. Like we see benchmarks that really blow off the water, out of the water, like things that we thought uh, were almost impossible. But just to give a few examples, we were asked to look into a legal case by one of our investors, and they obviously employed a very respectable law firm with they're using their own AIs and paralegals and analysts, etc. Been working on the case for a while, and we were asked to put the case, just ingest all the correspondence, all the relevant files into AeroGenie and see what we think. And usually when you think about, like, say, if you go like a deep search or whatnot with any of the chatbots, it will take hours. And even though it gives you a very detailed answer, it's still limited to the trade-offs I mentioned. It doesn't do any simulations. So long story short, AeroGenie came back with about after like a minute or so. And in terms of tokens, it cost about $1.86. I still remember that number. And it said, look, you guys, the team has been looking at the case in the wrong way. It should be treated as a different type of case. We highly advise that you stop what you're doing and file so-and-so motion. Otherwise, if you continue in this way, the probability of you winning the case is this, the payoff is that. Everything with very detailed analysis and reasoning. And therefore, we recommend after testing this that you should actually treat this case as a different type of case, go with this type of strategy, file these motions. And if you do this, probability of winning is this type of probability, and the payoff is going to be something else. And we're like, okay, that's just a recommendation. Let's bring it to the legal team. They looked at it and they were like, yeah, unfortunately, it did found vulnerability we hadn't been aware of, and it makes a lot more sense. That's the case number one. Maybe just another one to show the versatility of it. Another use case that a cosmetics related company came to us and said, hey, we're about to launch this new product. And we tested this ourselves and also used other LLMs to test this and research. And we came to the conclusion that this product should cost $75. And again, same idea. Can you please feed up all this information into AeroGenie and see what it would recommend? So AeroGenie created its own engines, like once and own agents. Like so, once it understood the mission, it said, "Okay, I got you." Develop its own skills, checked, for example, in Amazon marketplaces and in other places, and said, "Look, we disagree with your recommendation. The competitive landscape does not justify anywhere near $75. It should be around $45. And here's the rationale." And eventually, the firm or the company decided to follow our recommendation because it was so detailed, and the rationale was like step by step how and like the sources and how the AeroGenie came to this conclusion. But point being, it did not miss something that other LLMs and other research I'd missed in the get-go. All this, and again, in like a few minutes. So that also was something very surprising to us. Maybe one last case is we also looked into this to stress test some investing strategy, like a portfolio, how like the composition of a portfolio and what we should do. And again, like 2 years ago, we predicted accurately a certain, for example, a certain movement in Palantir stock and a few other things. It's like, okay, that's very interesting. With again a combination of both machine learning and simulations.
Mm-hmm. Awesome. That sounds that sounds like a miracle, you know. But still, what are simulations? You mentioned that it can run like thousands of simulations per second. What are simulations?
It's a great question. Maybe it's worthwhile talking about simulations versus kind of like a pure machine learning approach. So a simulation, and there, I think the most known one is a Monte Carlo one, but there are other types of simulations. But the idea is that you take a data and you run an experiment multiple times and see where it converges. I'll give an example, like two very known examples, and then other interesting examples I just read recently of surprising industries that are using simulations. So let's say that I have a fair die, and I want to know what is the probability of getting any of the faces, like say 2, 3, 5, whatever that is. And assuming that I don't know much about probability, what I could do is I can like throw the dice once or twice or whatever, and after 10 times, I say, okay, let's see how many times I got the number 2 as a percentage or as a proportion of the 10 throws. So it might not be 1/6 of the time because it's only 10. But if I repeat this experiment 1,000 or 10,000 times, it's going to approach 1/6. Another interesting example, if people want to approximate the value of pi, the ratio of circumference to diameter, one thing that you can do is take a square, usually people have like 1/4 of a circle inscribed in, and then you can like throw dots. So imagine that you have uniform distribution that you just like throw dots, and then you count the portion of the dots inside versus to the total square, and you can infer pi from this. The strength of it is that you don't have to train a model. So like the machine learning approach is something like this. Whatever model you use, by the way, both for supervised learning and unsupervised learning, but the idea, let's say that you have something, let's take supervised learning, for example. Let's say that I want to forecast the price of a house. And step one, I have to decide what features or what parameters I want to use for building the model. I have to build the model, feed in the data, assuming I have data, which is a huge assumption, by the way. And then I have to train the data. And again, like the training set, cross validation, keep on refining, and then I have the test set. And then when I have a new house that I haven't seen, and the model would tell me, okay, the house should cost $1.1 million, like a point estimation based on the model I created. And assuming again that the model is not underfitting or underfitting, that's what it does. The vulnerability of this is that one, it presupposes I know all the parameters. Because if I find out that, wait a second, the other parameters did not take into consideration, I'll have to rebuild and retrain the model, which is a lot. The second challenge, it gives me just 1 point estimation. Yes, you can run like a chi-square analysis or other type of things to explain what features contributed to the variance and what explains the result, but it doesn't give you as much a probability distribution of what you received. And then in addition to that, a model can usually answer one type of or related types of questions. So if you have, like, let's say you and I asking very different questions, we'll probably have to build different models. And that's just not scalable. And simulations, on the other hand, you define a certain function. Like, for example, if I want to forecast profit, so profit is like revenue minus cost, for example. And in this case, by the way, an LLM, if you ask a question, can interpret what type of formula and type of data you need to answer that question. So with simulations, you don't have to build a model. You just run the experiment once, and then you repeat it multiple times, again, usually thousands of times, and see where you converge. And the thing is, it doesn't have to replace necessarily a machine learning model. It can either come before or after or with it. Example, let's say that I want to build a machine learning model, but I don't know what features to use. So I can probably run a simulation, and then as a second step, run the machine learning model on top of that based on what the simulation used as its parameters, and vice versa. Let's say that I have a machine learning model, I can run the simulations to see the probabilities that are associated with the results I get. Usually, simulations would reply with, here's the lower bound, upper bound, and the more, like what you call like the peak value, the most likely result you're going to get. And maybe one more thing I'll say is that a few interesting examples that I read that actually uses simulations, Formula One races. There's so many interesting parameters: the tire pressure, the type of the time of the year, the weather, the engine, the driver, so many other parameters, and they heavily use simulations to tell the driver, for example, when it should, what lap they should actually go for a pit stop. Taking into the consideration different times, like do they have to position, not to position before the race, and something that you think, well, it's just racing. It's extremely accurate, extremely data driven, and they heavily use simulations because of that.
Okay, you got me really interested. So, that's
Happy to
awesome.
share the article I just read in the F1 magazine, just how they use simulation in that type of use case.
Okay. In your legal case, for example, how do you run this simulation? So you got, I don't know how many pages, hundreds of pages of legal documents. You need to load them, and what do you simulate? You simulate the outcome based on some decisions made, or
Yeah, so like oversimplifying a bit, but step one is ingesting all the data. And because we built what we built, we're using Mojo and other optimizations, we can actually ingest millions of pages. And I've seen like millions of lines of databases without skipping anything. And we also have a module that use the uploaded documents and translates them into structured data. So we can actually use that also as part of the model. And then run different stress cases, like for example, different parameters and like different legal cases that have different similarities or different commonalities with our case, and see how they ended, like who was the judge, like what was tried, what type of court, which state, etc. There's so many parameters, and what happens if you change the type of the case to this versus that. And again, thousands of simulations that run per second, and you let it run obviously for multiple seconds, so you have a lot of type of data and stress testing different scenarios. Like, what if I do this? What if I do that? So that what if is something that LLMs are not designed to do. And maybe one thing, I mean, it can sound kind of like I'm bashing LLMs and chatbots. I think they're amazing. I think that they're definitely a leap. Like it's a step function from what we had before. It's not just an evolution of something that just becomes a bit better. They're amazing. But the way I see them, they're more like a proof of concept, meaning if you think of OpenAI, Anthropic, etc., they built wonderful things. But in some ways, they build them as more like a proof of concept. They look for companies and people like us to say, okay, what can you do with this? This is like a beautiful tool. How can you use this? There's some built-in limitations. For example, if I'm a Rolls-Royce and I build engines, by definition, by design, I don't also build the planes or the cars or where the engines goes into. That's something that we need to do. So we took and by the way, with AeroGenie, you can use whatever LLM model that you like. Deploy it locally on the cloud, whatever it is. But the point is we give the right environment for the engine to run in an optimal way. That's why we use the other technologies that we put with it to run with this. So again, LLMs are awesome, chatbots are great for what they were designed to do. But when they end, this is where we begin.
yeah, awesome. So how do you make this mixture of simulations and usage of LLMs? At which point, which steps in? Like obviously, LLMs like give the end answer in human readable format, right? but how do you make? For instance, legal case, you got hundreds of documents of the case. But besides that, you mentioned you need to take all the potential other cases from around the internet, right? Collect them somehow, and then on top of all of that data corpus, right, run some simulations. So probably there is some LLM in decision making, what to collect, what to bring, what to get. You mentioned Amazon, so there should be some LLM that has written, I don't know, some piece of Python to get the data from Amazon, and then feed all that information into your simulation engine, which produces some kind of result, and then LLM steps in to make the final judgment call. Well, could you like tell us more about how it works underneath? How do you combine all this? Like where your engine steps in after LLM ends, as you said.
So the LLM again, I mean, like, today LLMs obviously can work with
Yeah,
agents,
yeah.
and you can configure them, and you can build your own.
But
As
it's
I
not
mentioned,
$1, it's not $1 cost.
but that's the thing, because if you think about LLMs again and chatbots today as more like proof of concepts, they show you what's possible, and they say, can you take this, like what you say um, in the storefront, and build something with it? So this is where we are. So uh, I think a huge part of it is because we built a lot of the technology using Mojo. And we also put a lot of time optimizing the functions that go alongside. And we have a list of all the functions and how they compare to the Python. And again, when I looked at that comparison, it ranges between um, like 200 times faster to about like over 1,000 sometimes faster. So that allows you to see more data and run these simulations. Now, when you ask how, so obviously the LLM can tell you, here's what like for example, in the simulations, how we should think about the simulation. Here's the relevant data and the formula and the relation between those components. An interesting point, just to pause for a second, an LLM will hallucinate because of the trade-offs. They don't have all the data, or they would skip. They wouldn't, instead of joining 5 tables, they only join 3, for example. With us, we don't have to make these trade-offs, and we will actually flag out, we can't answer this question because you're missing so and so data. So actually, other than just agreeing with the user and say yes, of course, and approximating, we'll say, here's something we can answer. Here's like data that we're missing, we cannot replicate. So here's the vulnerability in the answer. And the question that you ask about building the agents, again, I think it also comes because of the speed. Because think about this way, I mean, like every agent that runs today is subjected to the same trade-offs and limitations or budgets that the LM has. Like, for example, I have so much time as an agent to return an answer, so much time to compute it and computing resources, and so much tokens I can spend on it. So if another agent is dependent on my answer, that limits I have to approximate just by design. So we're for the most part, we're not bounded by this type of limitation. So that gives you some idea of like the approach we took. And the big surprise was that we say, okay, what happens when you no longer have to make these type of trade-offs? What would that look like in terms of the quality of the decisions, the answers? Because the way we thought about AeroGenie, like ideally, it's not that you actually just put prompt. You like the same way that you do with Cursor and others. You can put prompts and you'll get the decisions. But ideally, we want AeroGenie to ingest things automatically, make the decisions, and ideally also execute. Maybe just one example that might be relevant. The past few years, I spent um, my career in the cybersecurity space. So imagine you have a threat detection and response system that identifies a vulnerability, or even like say maybe there's a breach or something. So imagine that AeroGenie ingests this data, can read the logs, unlike any other machine today. Again, like read the millions of lines in so many logs, and decides exactly what the problem is, what to mitigate and how to mitigate, and then what actions to take based on what it found. So this kind of like end to end, that's our vision. But of course, people can use it in like anywhere in between. Ingest the thing and then use the recommendations to be executed by the SecOps team or the CISO, whatever, themselves. But just to show that the system was designed to do everything from start to finish.
But do you understand it right that it needs a lot of data, basically, to be able,
Yes,
besides the case itself, it needs to collect all the related data to be able to make to find this like the most possible statistical outcome of the
absolutely,
simulation.
absolutely.
So in case of legal cases, you take your case, but you also grab all the possible cases from the internet, similar cases, and then
Internet and databases that legal database connect to.
in case of logs in cybersecurity, you got your log file, but besides, you need to have all the similar cases found over the internet.
It's not just the internet, but you can use your own database, your own logs to see, like, say that you're company X and you already have uh, uh, threat detection or other, like, whatever firewalls. They collect data and you have it. It's just that it's like the data is so big that people find it very hard to digest and analyze and synthesize. And now with the advent of strong LLMs and technologies like ours, you can do things that you couldn't do before. So the companies in many cases have this data. They sit on trove of extremely valuable data. They just they don't have the capacity to make the best of it.
Absolutely. Now that I think of it, I've had a lot of discussions with travel industry, and one of the biggest concerns are like um, not the concerns. One of the biggest like troubles is customer support itself. And but the problem is, or, yeah, the question is that these companies sit on a lot of data, like 10, 20, 30 years of data. And all these cases that or potential cases that are happening nowadays with some certain client, they did happen before over the last 10 or 30 years. And like the biggest problem for them is how to extract that kind of data, because you cannot just feed everything into LLM. You can use some RAG approaches, whatever approaches, you can structure the data somehow for LLM to use, but it's slow and it requires a lot of work. From what I hear from you, you can just feed all the data in AeroGenie, and it gives the result in a matter of like seconds or minutes.
Yeah, and the thing is, Origin doesn't have necessarily to replace these systems. It can sit as the brain behind them. So it could be, for example, that you have another chat support or whatever it is that you have. Again, there are other companies that build this kind of type of systems, but for the decision, the quality decision, especially in what, let's take your example, in what cases to compensate, what type of compensation based on so many other parameters. A simulation might be faster in many cases and give you more quality decisions alongside a machine learning. And as you said, I mean, companies do have this data, and it's extremely exciting to see what could be done with it.
For sure. Maybe last question about the product itself is how did you make it generic? I can understand how to make it for specific case, but how did you make it generic so that you can throw in legal data, throw in some beauty goods, and whatever else?
I love this question because if you think about this, and think about like the way we thought about this. What is the DNA of a decision? What does it look like? A decision look like? So sometimes, and people are looking for answers, not just decisions. And maybe it's worthwhile defining what we think of, like what is a decision. And then I think from that you'll see why it's so generic. So an answer, let's say that before the chatbots were available, you go like to your favorite search engine, ask something, will crawl the internet like very efficiently, gives you like a bunch of things that you have to choose from. And if you ask a question, I have these symptoms, that symptoms. Now with LLMs, you can add your own context, either through RAG or MCP, or otherwise that you just put in the prompt a bit more, that you can do much more than traditional search engine. But the thing is, if you think about a decision, and this is where I think the shortcomings of chatbots, for example, is that you want to be able to replay. Like, for example, if you made a decision, like say 2 months ago, to shut down this line or increase the price of that, and you're asked to defend your decision, you want to make sure that the data that was used at the time, that might have changed since, hasn't been lost, that you can still replay it the way it was at the time of the decision to justify it. You want to see a clear reasoning. And again, some channels will give you like the sources, whatnot, but not as clear reasoning of exactly what led to the decision to defend it. And when you thought about this, and you want to be able to make sure that you looked at all the relevant alternatives. That's kind of with the simulations, like the what if. What if the fuel prices go here? What if the yen devalues against the dollar? What if this? What if that? It obviously would impact my sales cycle, my inventory, et cetera, et cetera. So when we thought about this generically, we say, okay, so first of all, you need to be able to ingest data, because that is like the main limitation. I need to decide what data to ingest and to be able to do it without sacrificing or trading off anything important. And the approximation that most LLMs do is great for like an initial direction. And for many answers or many questions people are asking over the internet. Like, show me my favorite restaurants here and where should I go this, and give me like a recommendation for a movie I should watch based on my criteria. But if you need to make a complex, critical decision, complex that it has a lot of data, it's very hard to make a decision. Critical in the sense that you have to defend it and a lot is at stake. I can't just rely on LM to do this itself. And that type of topology is something that is very generic. If you think about it, it could be, you can inject any context or any data. You don't have to train anything because, again, we're using simulations. You don't have to have a pre-trained model for this. We can build skills, we can build agents, but then we thought, okay, what if AeroGenie can build its own agents?
So you kind of make a lot of small hypotheses and just continuously adjust the solution, right?
Yeah, and eventually, so when we built it, you built it in the sense that there was no hypothesis was unique to the company who asked us to initially build this thing. And then it's just a matter of curiosity. Wait a second, if that's the case, let's test it. I'll give you another interesting use case that we just tested because Angel, our CTO, we didn't know if it would work. We just tried it. So my brother has another company in the defense industry, and he has a huge deck, like 120 or so slides, like very complex deck that he tried to shorten with different LLMs, different services. It didn't go anywhere. And he's like, see if you can make anything out of it. We fed it into AeroGenie. First of all, before anything, it spat out a very interesting chart, a flow chart, like almost like a stream of consciousness of how it understood what was presented to it, the various personas, the various motions, etc. And eventually said, okay, here's how I would recommend breaking it down. And it did break it down into separate slides, shortened with the personas in mind. Something that, again, we didn't tell it. It just had to think about the mission and break it down themselves. And interestingly enough, we asked AeroGenie, how would you market yourself? We tried to take you to market. And we also, can you please also create a deck for our investors? And again, for a deck, for example, it looked by itself on our website, took the colors, the themes, the look and feel, the fonts and everything, built a deck. And for the first time, I didn't have to change almost anything in the deck. Like the content was spot on. I mean, like I liked a certain design I did better, so I changed like 5% of the design I did there, but it was pretty much good as is. The pricing strategy, the go-to-market, what to focus, etc. AeroGenie ran on itself to get this type of answer.
So,
Yeah.
that's amazing. Is there still some LLM behind it? Or
Yeah, of course.
Yeah.
So the LLM is used to understand the intention. So for example, if you put a prompt or something is being ingested, LLMs are again extremely critical to interpret the intention, right? Like, what exactly did you mean? Like, for example, maybe you and I want the same thing or something similar, but use different words. So an LLM is really good at understanding your nuance and colors versus what I meant. So that's kind of like where we use LLM in the initial understanding. And then from then we say, okay, we got you. Then we go, and again, even how to devise the simulations, what to consider, what not to consider. LLMs are extremely useful there. We just, again, the execution part of it, they are limited in certain ways that we're not.
Yeah. Awesome. So how do you go to market with this still? What did it suggest you?
So first of all, again, the pricing strategy is interesting, the per user per month and how to go about this. And again, in a couple more months, I think it should be available to the public. Right now, we're just in the process of launching it, creating the usual, the YouTube, the LinkedIn pages, the splash pages, etc. A few videos. And surprisingly, by the way, we just uploaded one video that already had We barely boosted it, to be honest, like a few bucks a day or something like that, and we had of those like about 30 or 40% conversion into subscribers, which to me is very interesting for a single video that is so friendly. It's like 6 minutes. It's, to be honest, again, I our CTO put it there, and I was like, okay, let's see. And we will focus on, at least initially, on business users that are no strangers to chatbots. They need to know how to use chatbots. They need to be, if for example you're told, hey, use MCP to connect so and so services. We want people that are comfortable with this thing, and therefore we're going to put it in at the same time. We'll open into like a focus group, and then to
I
others as
am
well.
comfortable.
Happy to again, happy to do this again. The goal is to put it in the hands of as many people to try it out. I should say, obviously, it should have also a free tier that people can try it out, see for themselves. But the idea is really to test it against, like, and we hopefully we'll have some testing again. We'll show this how it actually works compared to any chatbot that you have today in the market. Not to make chatbots look bad, but to show this is the extent that chatbots are great, and we take it from here and run. So, for example, you'll see the approximations that they make in different types of questions or decisions that you have to make that relies on data. Maybe one simple case that is easy to try is, let's say that you have a huge Excel or CSV. Again, most accounting system, for example, or others can produce huge CSVs. And an LLM would have to skip lines, even though like, I think a CSV can have up to, if I'm not mistaken, like 2 million or so lines. An LLM would not read 2 million lines. If you upload a PDF that has 200 pages, even though it's well within the, like 200 or 300 kilobytes at most, an LLM will skip pages.
Yeah, it will not fit the context window. So LLM will write some piece of Python code.
But they're not designed to do this. That's the point. I mean, like I don't fault LLMs for that. That they're, or chatbots. I mean, like, LLMs are amazing. They're amazing. You know, I don't know if you saw that the recent, I think, NVIDIA announcement that they're going to have like 1 trillion or so parameters, and also follow closely Andrew Ng that covers these kind of things. What we see today, and that the evolution is so fast, but I still think it's directed in certain limitations. Like, for example, at least at this point, simulations are not part of it because of the token and CPU limitations or memory limitations. And LLMs, again, they're good for certain things, but they have a specific usage.
Yeah, LLMs have limited context window, and LLMs are statistically pre-trained, and whatever
Yes.
they were
Yeah.
trained on, they can
Exactly.
produce something. From what I hear from you, you can run, like, you can not retrain, but you can take some corpus of data and try simulation on top of that corpus.
Yeah.
Yeah,
Again, you just upload like a very heavy Excel and see if you can ask questions.
awesome.
Yeah.
Are you considering some B2B clients, or is it rather B2C? Because it should be uh, quite interesting for B2B users, for
No,
business.
absolutely. So I mentioned the cases of like cybersecurity. We're going to try. I have some still like strong and warm ties to this industry. Going to try and put it in their hands and see what they make of it. And again, it could be used in different ways, anywhere from the actual patching or taking the actions or telling you based on the logs what could be done. Any way to automating these decisions. Again, working with whatever systems you have today to both ingest but also execute autonomously. We already have a chain of restaurants, like a large chain of restaurants that wanted to take a look at this and use it for different ways. Hotels as well. I see a lot of B2B again. We talk about law type of or litigations type of usages. I know law firms today use something called co-counsel, and they obviously have their own regulations. But I'll give you just maybe one interesting use case that we found out for law firms: the accepting of new clients. Usually, you have to have analysts and paralegals. Let's say that I'm a new customer and I want to submit my case to a certain law company. I'll give them all my correspondence and the files and the data. Someone has to go through this and say, okay, is this a good fit for our firm? Can we take it? Do we have the capacity? Will it make sense for us to take it? Is this in our expertise, et cetera, et cetera? Imagine that instead of paying people to do something like this, you ingest it almost automatically. AeroGenie goes for this in a few minutes, gives you the right rationale and the right decision what to do with this case. So you don't have to replace anything they're using today. It's just really more uh, the ability to handle more customers at scale, for example. Not to mention, by the way, again, our bread and butter is the aviation space. I definitely see a lot of use cases. Again, this is such a complex and regulated industry that there's so many decisions they need to make, anywhere from like CFOs to operations, to go to market, and what parts to have and not to have, etc. All these things, all these decisions are imperfect today, and something that can definitely be augmented and much improved with a technology like AeroGenie.
For sure, aerospace should be interested, especially since I know they are running on very thin margin and they do care a lot about margin. And any kind of operational efficiency for them is a big boost in their margins.
Any decision that you want to take, like for example, should I open a new airport in so and so location? Should I open a new, like I said, I'm a developer. Should I buy an office building? How tall? Or should I build a hotel? Or what? All these type of decisions, think about it. They're very abstract, but they do require a lot of data. And they do, like you need someone smart to, much smarter than us to consult with and brainstorm ideas. That's where I think a technology like this comes to life.
Sure. How big is the team standing behind this product and this development?
Surprisingly small. Surprisingly small.
I guess so.
We're fewer than 10 people in the development team. And again, in my experience, usually when you want to build something like this, and maybe I think it's worth saying a few words about. I think this is a very interesting question. In my experience, you'd have to have a product management team, not just one person, a team of engineers, marketers, etc., to build this. And why? Because at the time, way back when, engineering resources were very expensive, and it took a lot of time to build and test and refine with the customer that you actually got what you wanted. But today, with the beauty of AI assistant coding and other ways to accelerate coding, engineering has become, again, if you have the right resources, relatively uh, quick and relatively cheaper compared to the other options. So it's really more a question of like, what should I build? And how do I decide about that? And how do I converge from different hypotheses to the right solution?
Especially nowadays, you cannot build this kind of system with a big team. So
No,
if you want to move fast, you need to have a small team and empowered by all these modern tools that are around.
it's almost like close to zero fat. I mean, I've been in different organizations, work with wonderful people, but it's a very like almost like futuristic type of feeling to work with people that you can see every person exactly what value they bring and how they augment themselves with AI today. And by the way, when we are thinking about hiring people, that's exactly how we're thinking about. Can this person create a force multiplier by bringing themselves into the equation? Because just like bringing one more person, however talented they might be, that's one thing. But if this person has access to knowledge and how to use different AI and other systems, by the way, to really, like for example, marketing. Used to have again, I manage teams of like sometimes 20 plus people, and and then a bunch of agencies to execute on different things, anywhere from like videos to campaigns, etc. Imagine now that you can need like about like 1/10 of the people to do the exact same thing, and probably in even better quality.
Awesome. What are typical challenges that you have in your development? What are usual?
Really where to focus, to be honest. It's like really, um, given that everything you want to build, if you build too much, then the go-to-market becomes a bottleneck, like selling it, marketing it, supporting customers. So in many cases, we'll have to say no to customers that they want something that can actually make us like decent amount of money just because it's going to be like a one-off. We're trying at least today to stay away from being a project-based company and become, because I think like Palantir is doing an amazing job. I don't want to become another Palantir for that matter. We try to democratize some of their capabilities, for example, but not at the expense of having to support, like, tens of different custom deployments that are not scalable. I think scalability is the key. And for us, what to say no to is I think is still very challenging, and where to put our bets. And just to give you some criteria, where I'm evaluating today, like new directions to take to market, I have two things. One, the applicability, like, is it really relevant for like a small niche or like a relatively bigger niche of customers? And then, is it deployment fast? So if I need to be bogged down like in months or a few weeks of deployment, I'd rather go for something that I can deploy it almost instantly. Again, AeroGenie, let's say that you have access to it, you can say, hey, Yuval, I got it from here. You can connect to MCP. If you don't know something, you ask AeroGenie itself. Hey, can you tell me exactly how to, where you mentioned a shareable data link. How do I get a shareable data link? I have this Oracle 19C. How do I do this? Boom, 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 go do it. So you don't really need me, and you don't need to have me to deploy anything per se. And this is to me like where the future is going. Something that the customer is kind of self-empowered to use it almost from the get-go and run all the customizations, all they need to do themselves.
Yeah, yeah, sure. That's a great problem to have, of saying no to your customers.
It's true, because the thing is, sometimes your capabilities could become your own curse, because then you end up with different customers. They pay you and everything, but each has its own need. And when they have a challenge or you need to upgrade the system, you have to do it separately for each customer. And that to me is not scalable. It goes again to have like a small and lean team that can execute at scale.
And that's great that you have your focus and you execute on it. Uh, how do you see the nearest future with this kind of tools? Because these tools are emerging and they're quite powerful. What do you think about, it's some philosophical question. It's not, business related or anything, but the future is changing and it's changing rapidly.
You're absolutely right. You're absolutely right. It's very hard to predict something that it is constantly changing. And again, I'll tell you a quick story. So we had a version of AeroGenie about maybe a year and a half ago, a bit even more. That was very innovative at the time. Like, you can have, like, for example, graphs and charts done in line within your questionnaire, including certain machine learning analysis, like a PCA analysis and this and correlations inside AeroGenie. But we had a tough time explaining to people how to use it. Like, it was really relevant for very sophisticated data analysts, and at some point we kind of like lost, like after like 6 months or a year, we lost that advantage. Now most LLMs already have these capabilities, and it's very hard to catch up. And I think you'll see like releases in the staggering rate. Like, that means that you'll see more innovations from the likes of Anthropic and OpenAI and Google, etc. And computation is going to become much more efficient. We're not doing anything that others are probably not doing today. We didn't invent Mojo. Others are using Mojo. We just, again, took different technologies, pieced it together in a certain way. But I do think that LLMs would offer more. They will be able to ingest more in the future. But at the same time, I think the business model for the time being would either to offer LLMs for specific industries, like, for example, what Microsoft does with, I think they call it Dragon, for the healthcare, or like special types of LLMs that are pre-trained for certain things. And there are other companies that I think that's their specialty. But nonetheless, I still believe that there's going to be room, like people like us, like companies like us, that would always take LLMs from where they stop and extend it further. Because again, you can't solve for everybody for everything. And I definitely also think that the agentic AI usage is going to be much more prevalent than it is today. People like in the earliest time of LLMs, people just asked questions, received answers, and moved on. But people becoming more technically competent and comfortable exploring things, especially that, again, the LLM companies are doing such a great job making all these technologies accessible. Again, MCP. Imagine that before you need to have like a very talented data engineer to do certain things. And today with MCPs, you can do so much more yourself. And again, think of the transition from RAG to AC to MCP, for example. All these things, I expect them to continue happening in the future.
Yeah, for sure. Uh, yeah, LLM will be becoming more capable, and quite likely they will become specialized. That's what if Andrei Karpatin like mentioned a lot of times in his interviews. But what he extended them with is with statistical simulations and on big corpus of data. This is something where I do not even see them moving. This is something completely different. They train statistical models on big corpus of data, and that's it. And while you take your unique corpus and run simulations, that's very powerful simulation combination for me. It seems, and from what you're saying, it works. So it indeed is. So awesome.
Most companies that use simulations, they have a well-defined problem. Again, I gave the F1, the Formula One example before this, so they already know that their parameters and they're focused on that. But if you're thinking of building something that is like multi-purpose, and how can I democratize the simulations across different use case industries? That's not something that the F1 folks are thinking about. Again, they care about Formula One. And chatbots may look into this in the future. I definitely think it's a possibility, but they'll have to be specialized in so many other things because, again, how do you solve for agents' limited budget? You can't approximate, you can't run thousands of simulations per second with the current technology, and you can't run thousand simulations with that eventually going to cost you hundreds of dollars per query. That's where the option would be today if you were, which you can't run it with LLMs today.
They're too generic and they're targeted on mass market, while you are targeted on some solving specific problems, deep solving these problems. And that's also
Exactly.
awesome. That was really uh, like inspirational, great discussion. And
No, I'm glad
uh,
you found it useful. And again, I'm happy. In the next few weeks, it's going to be limited beta. I'll give you an access if you're interested. Playing with it, what you make of it.
I'm your first user for sure as soon as you open it. Awesome. Thanks a lot for this conversation. Is there anything else you would like to add on top of what we discussed before we wrap it up?
No, again, thanks so much for inviting me. It's been great. I think we're living in a very interesting time today,
That's
and
for sure.
I think maybe one positive message is that it opens creativity for pretty much anyone. So if you thought before, let's say that you had an idea for uh, a project, a startup, whatever, and like, oh, where do I find my technical person, and how do I create a team in marketing? Today, a team of one can do so many things, and again, like maybe like even like a small team of like a couple of people can do what I think in the past you need to have like 20 or 30 people do. And people, once they realize that, I think that the opportunities are endless.
It empowers you extremely. I got fed up with one of the tools I'm using, and I just asked Claude 2 weeks ago, can we reproduce it? And Claude was like, yeah, sure, why not? And like 2 weeks later, I ready. Prototype was ready in the first night, but 2 weeks later, I am close to like put it as an MVP to some users and run some traffic towards that product. It's it's
Exactly.
it's so weird. That would take otherwise a big team, engineering team, product team, designers, all these people working together, marketing people. Nowadays, it's one person. And 2 weeks now. And it's between regular work, so everyday work.
Yeah. But surprisingly, I still find that the human element still critical. Like, for example, take marketing. Yes, our marketing team, small as it is, can do amazing things, but I still like to talk to a human at the end of the day and see, can people empathize with what we're doing? It's like a machine can get you so far, and I would assume can really emulate human emotions really well. But again, psychologically, it's still deep inside. I'd like when we have marketing, there's a person I can talk to. So, and again, maybe that's going to change in the future. You never know, like 10 years or 5 years from now, may look different. But I think you definitely need people in critical places just because, again, we talk to each other right now. Imagine that it's going to be two machines talking to each other instead of the podcast. There's still a huge element of like two people talking, exchanging ideas.
Yeah, Internet of Agents. Yeah. Awesome. Thanks a lot. Thanks a lot for the discussion, and good luck with release. And let me know when you're in beta.
Absolutely. Again, thanks for having me.
Yeah. Cheers.
Thank you.